A really nice step two question here from 2021, question number 3. I really love the questions where they give you something you've probably never seen before, so some definitions. So floor function of x being the integer part of it, and squiggly function of x being the decimal part of the number. And the decimal part is defined to be positive. That's going to be quite useful to us. And then they give you these definitions, and then they just ask you to do a relatively easy question, a medium question with some help as well, and then a really hard question with no help. And also, even better, the really hard question relates to the medium question really nicely in a nice way. So lots of really good stuff in here. Really nice question that I wanted to do. So again, this is the integer part. So this is an integer number. This is the decimal part, the squiggly part. So therefore, it's as simple as saying, well, this must be 0.9 and this must be 4. Now, the other thing that could happen is this could be a minus 0.1, and that could be a 5, but this is defined to be positive. So that's the first case where we'll be using that. It's defined to be positive, so it must be 0.9, and that must be 4. That's the only choice. And down here, again, this can't be negative here, so this must be, but that can be. So how are we getting this? Well, we can't be using minus 1, minus 0.4. That can't be what we do. So we must be using minus 2, and then a plus 0.6. Very much like the example they've actually given you here, which is very helpful to us, that this squiggly part doesn't actually refer to the decimal part here, because of this case here. So quite helpful example there they gave you. But anyway, now we can work out x by doing, of course, x is floor plus squirrels. So these two added together make 4.6, and those two added together make minus 1.1, and we end up with our first solution done. For number 2, or part 2, we've got a 3-dimensional simultaneous equation, of course, and we're being asked to show this first. They think that would be helpful to us. So the first thing I noticed was that if we just add, or we can name the equations 1, 2, and 3, if we add 2 and 3 together, that those two there at least come together to make a whole x. So that seems like a useful thing to do. So I add them together. They make a whole x there, and everything else. These don't go together so well, really. So I'll just leave those there for now. If I call that equation number 4, though, and now if we look at equation 4 and we go, okay, well, there's anything else I can use here. I haven't used equation 1 yet. So why don't I do equation 1 plus 4? Because x plus x is 2x. And then floor of y plus squirrels of y is y. Added with the other y is 2y. And then likewise for the z's. And we just end up with 2x plus 2y plus 2z is that. Divide everything by 2. That seemed like quite a useful equation to keep. So I call it number 5. I'll keep it around for later. But now how do we finally get to here? Well, actually, let's look at this one here, and maybe let's look at. And the other thing you can do is rather than looking for these things, what I was actually doing was trying to make this thing. How do I make a 3.2? I was constantly keeping track of the numbers and thinking what things can I put together to make a 3.2. And I saw it here. That's the difference of 3.2. So if I do this one, take away this one, that definitely makes 3.2. Do these come together to make this thing here? Well, they do, right? Because just the x and the y and the z just go away. So we end up with what they wanted us to get. So yeah, using all the resources available to you. Anyway, we have this, and now we can do what we did before. This must be 0.2, that must be 3. As we said before, in the first case, when we had squiggles plus 4 equals a number, we can just assign them like we did there. So that's what we're going to do. Sorry, that was what we just did here. And now, of course, we can take maybe all of these equations. We can't really do anything with this because we didn't find either of those two things. But this one, floor of z is 3, so take it away from both sides. Here, squiggles of y is 0.2, take it away from both sides. And let's see if we can make any progress here. Now, this is not as easy because it's not floor plus squiggles, it's floor plus a regular number, or squiggles plus a regular number. So this isn't as easy to say, but let's think about this one carefully. This is definitely an integer. And the answer ends in a 0.8, which means that z must just be, the decimal part of z must just be 0.8. Now it could, and I thought about this for a while, it could be 0.2 though, could it not? Like, because if floor of z was 6, and floor of x was 6, and z was minus 1.2, that would totally work, right? And the decimal part of z would be 0.2, except it wouldn't. Because notice the example up here. When x is a negative number like this, the squiggle part of x isn't 0.2, it's positive 0.8, and then this would go down to be minus 5. So if I was trying to do that 6 minus 1.2 example, the decimal of z would be, if it was minus 1.2, the floor of z would be minus 2. The decimal of it would still be 0.8 to make it into minus 2. So this actually can't happen. I was trying to play around with this. It actually can't happen. Squiggle of z must be 0.8, I think, which means z must be, of course, 3 plus 0.8 is 3.8. So that's our first one got. So that's great, which means from here, floor of x must be 1. So that's very helpful. I wrote it down there. And of course, I can put that in there, and this seems quite helpful as well, when you put z into there to get this. And now what more progress can we make? Well, I decided to, I think this is me writing out this equation here without the squirrels of z in it, taking away from both sides. And likewise, the next one down here, I think I wrote all three. Oh no, I didn't bother writing this one because I actually have everything in this one. But I wrote down these two. Again, floor of z is 3, so I can get this. That's actually what I wrote there. But anyway, now we can look at this one maybe. And we can say, well, that means that the squiggle part of x is 0.1 for the same reason we just said it was. The z part was up there, which means floor of y is 3. And therefore y is 2 points. Where have I done this from? So squiggle of x is 0.1, which means floor of y is 3. Sorry, I'm being an idiot. This is definitely 0.1, which means x is 1 plus 0.1, which is 1.1. And then 1.1 plus 2.2 is 3.3. Yeah, perfect. I was getting, that's not that, is it? So that doesn't work. Okay, cool. But anyway, the solution is z is this, x is this, y is this. And now we have our third part of the question, which is this. And what we can immediately see is if we notice this equation we just did, which had answers this, how similar are these two things? That's always what you want to look at for step. How similar are these two things? Well, actually, they're the same, just with all of the y bits being replaced with a 2. So I think that logically means a solution to this should be x equals this, 2y equals this, and z equals that, which means, of course, you get this solution here. Now, is that the only solution? Is that even a correct solution? Is my logic there definitely correct? I mean, I think it is, but also that seems like quite an easy thing to say at the end. I mean, I know it's spotting that is the trick there, but why don't we just check? Why don't we go through it nice and carefully? Why don't we? The other thing you always do in step right is try and replicate their hint in your questions. So that they haven't given you a hint here, but they did here. Try and replicate this. Let's just do the same stuff. I mean, like I said, the equations are basically the same. So I think I can do largely the same idea. So 2 plus 3 is where I started. I think that's where I started last time. Call it 4. Then I did 4 minus 1. I think that's actually slightly different to what I did last time, but I think it works pretty well. As this is 4 minus 1. The x's cancel, of course, which is nice. And now this here, factorize out the 2 from that, and it becomes y minus y floored. Which y minus y floored is just squiggles of y. So that's quite useful. And then, of course, you add another 2 squiggles and get 4 of them in total. And then, of course, this, I've done the same here. Z minus Z squiggle is just Z floor from that equation. So you get 2 of those. Now, if you divide everything by 2, you get this equation here, which seems quite useful. That's basically the equation we just came up with before, isn't it? I've just done it in, I think, a slightly more efficient way. But it's basically the equation that we just came up to, replacing y with 2y. Now, this is where we need to be careful, because pretty clear that we could have z floor is 3 and 2 squirrels of y is 0.2, therefore making squirrels of y 0.1. That's pretty obviously a solution. Except there is another. And it's because of this doubling of the squiggles means that this can be over 1, can be a bigger number than 1. If y squirrels was 0.6, this makes 1.2, and z floor is just 2. So we actually have 2 answers to this potentially. And now what I wanted to do here was do the black one first, shove these results into here. So the top equation doesn't change. The next one, we take away 3 from both sides. And the last one, we take away 1.2 from both sides. And let's solve these 2 equations. Of course, this means x squiggle is 0.3. Sorry, from here, let's go here first, I guess. This means z squiggle is 0.8. Sorry, x squiggle 0.3 doesn't work because this is an integer. So from here, z squiggle is 0.8, as we were talking about before, which means z itself is 3.8. And it also means, of course, that floor of x is 1, once you know z is 3.8, which means you can then go up to here with knowing z squiggle knowing this is 0.8, take it away from both sides. And you can say from here, well, there's a 0.1 remainder. This is an integer, therefore this is 0.1, and therefore 2 of the floor of y is going to be, because x is 1.1, take 1.1 away from both sides. 2 of the floor of y is 2, so the floor of y is 1, which means y itself is 1.1 because we said its decimal part was 0.1 earlier. So that's our solution, which is the solution that I said probably existed from the transformation that we did earlier. That's the solution that I said probably existed. Now let's do the red one instead. Yes, that's the solution there. Let's do the red one instead. Now let's put these results into here. Everything looks pretty much the same, except the numbers are slightly different when we took these results away from here. Now, of course, from this one, I guess, we know that the decimal part of z is 0.8. And therefore, we know from here that we can, or that we now know that z is 2.8, I guess. And we also know the floor of x must be 1 if the whole of z is 2.8. From up here, we can now replace that value in there like we did before. We now know the decimal part of x is still 0.1, but x itself is now going to be 1.1 actually still. which means that the 2 floor of y is still 2, which means floor of y is still 1. But because the squiggly part of y was 0.6, now y is 1.6. And that's going to be the second answer that you get to this question. So yeah, I just really liked it because it did all the things I said earlier. But you also have to be very careful and think it through very carefully, the whole thing, particularly not to miss this second solution. You just have to think very carefully about whether or not there was anything more to this question than just that simple transformation. And even if you didn't spot the simple transformation, then maybe you just do it all through properly and you maybe then see that there are two cases. But yeah, I just thought it was a really nice question. So thanks for watching.